I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about outcome-based education regarding the subject mathematical transform techniques. In detail, we will discuss through this video lecture what is outcome-based education and Bloom's taxonomy, MTT, that is a short form of the subject, the course, the mathematical transform techniques, what is the syllabus, how which is designed, and MTT, the mathematical transform techniques regarding the subject, how the course outcomes, the course parameters are done, and program outcomes related to that, and course outcomes and program outcomes, how they are mapped. In detail, we are going to discuss in this video lecture. First, Bloom's taxonomy. This is the global language for the higher education. It has 6 levels. Remember, the first level, that is the course outcomes, which are framed based on this, using these levels. In the remember, we will just recall the information. The next one, recalling the information, we will identify, then understanding. So recalling, identifying, and we will apply for the solution, that is the third level. And all these 3, we will do the comparison, analyze. The next level is evaluate. The last one is create. So all the 5, we will do the assembling to create a new one. So these 6 levels are Bloom's taxonomy. Our course curriculum, that is MTT, the mathematical transform techniques, which is framed satisfying these 3 levels. This is the subject is being taught in our institute, the Institute of Aeronautical Engineering. 3 levels satisfying this complete the subject curriculum which is framed. So now we can see this mathematical transform techniques, which has 5 modules. The module 1, the Laplace Transform is taking place, for which totally 9 classes are allotted. The mathematical transform techniques, it has 5 modules. Module 1, Laplace Transform. Module 2, Fourier Transform. Module 3, Multiple Integrals. Module 4, Vector Differential Calculus. And Module 5, Partial Differential Equations. Coming to the point of Module 1, the Laplace Transform, the 9 classes, similarly, all the other 4 modules also, each 9 classes, totally 45 theory classes which are allocated for this course. And the syllabus, the definition of Laplace Transform. What is Laplace Transform? The background on which we will recalling the Laplace, the great mathematician, he has given the formula. From there, which will start. Transform, from where to where the transformation it is going to take. In the Laplace transform, linearity property, that is the property of the 2 functions which can be written as the Laplace of each function, piecewise continuous, that is, the Laplace transform, the existence, it should be exponential order and it should be piecewise continuous function. That is, the continuous function 0 to 5, 5 to 10, 5 to infinity. That is 0 to infinity, which is splitted. So discontinuous, but in the discontinuous, in the interval also at each point, it is continuous. That concept, all the properties regarding Laplace transform, that is first and second shifting theorems, change of scale property, derivatives and integrals. If the function f of t, which is multiplied by t, what is the defined formula? If it is divided by t, what is the defined formula? And periodic function. First, recalling what is periodic function? F of t plus capital T that is f of t plus capital T, which is equal to f of t. The capital T is a period. If you're adding the period also, the function remains same. So we have to recall the basic definition of periodic function, that to be connected to our Laplace transform. That is a second level we will move. And with these two, we will apply to our particular problem. So all 90% of our course curriculum, mathematical transform techniques, apply up to three levels, which is framed. So the Laplace transform. So this is the syllabus curriculum. And inverse Laplace transform. That is definition of inverse Laplace transform, linearity property, first and second shifting theorems. Almost what are the properties which are connected to Laplace transform? The same property here, which is multiplied by t, here multiplied by s. This is the understanding level 2. Convolution theorem apply, that is level 3, and application to ordinary differential equations. So this complete syllabus, the teacher, the faculty who is teaching the course, expecting the student should have the knowledge. So the complete the module 1, this is the syllabus which is framed. The second module is Fourier Transform. This is also 9 classes. Fourier integral theorem, from which we are obtaining Fourier sine and Fourier cosine. These two to do, just we will recall Fourier integral, and again we will be recalling even and odd functions, and we will obtain this Fourier and sine integral. From these we are obtaining Fourier transform and Fourier sine and cosine transform, properties of Fourier transform. This is all Fourier. Each Fourier, it has its inverse Fourier transforms, finite Fourier transform. If the limit range 0 to infinity all comes under infinite Fourier transform. In the syllabus, infinite, the word which is not there. So it is understood by default. Now Fourier sine and cosine transform, if it is there, integral 0 to infinity for this particular f of x sine px dx. So 0 to infinity, students' understanding level. So Bloom's, the second level which is satisfied there, understanding. So the complete, now we are going to discuss our syllabus. What is the faculty is expecting that the students should be able to gain the knowledge, the course objectives, everything we are going to discuss in this video lecture. So our module 3. The module 3 is multiple integrals. That is, in which double integral, that is evaluation of double integrals in Cartesian form, in polar form, that is which is in 2 dimension, that is x and y coordinates, and r and theta, that is radius and angle, which is given in polar coordinates. Change of order of integration. Because suppose the functions which are very difficult to integrate, the student should have the knowledge, very easy way to do the integration. So for which the change of order of integration, to evaluate the area, the integration which we are going to use, double integral, the Cartesian which is given in 2-dimensional, that is xy coordinate, we want to change into polar, that is evaluating in polar form, we want to evaluate it, that is radius and angle way, the transformation of coordinate system. So the faculty decided to, the student should possess this knowledge, for which the multiple integrals, the syllabus which is framed under double integrals. The next, the triple integrals. Evaluation of triple integrals in Cartesian coordinates, which is not given here in polar also, and it is understood. Evaluation of triple integrals, if it is there, Cartesian and polar. Volume of your region using triple integrals. Understanding level 2. Level 1, Bloom's, just we will be recalling the formulas. Whereas, whether the given, the area, we have to use double integration. The area bounded region, the limits we want it. X direction from way to way, y direction from way to way. And how to identify the given problem which is in triple integrals. Bloom's second level understanding. So everything the teacher, the faculty is expecting that the students should have this knowledge regarding our module 3, multiple integrals. The syllabus which is framed under double integral and triple integral. Now, our fourth module is vector differential calculus. Scalar, the student should recalling the information what he studied in lower classes. Scalar which has only magnitude. Vector, not only magnitude, it has direction also. So now our given function, it has both magnitude and direction, that is vector point function. The definition of gradient, that is short form grade. The symbol, it's an inverted triangle. I, j, k, the mutually perpendicular vectors, they're connected to x and y, z directions. The differentiation partially towards that. Divergent. Grade, the dot product of grade and vector function, which will become scalar. Curl, that is a cross product, grade cross the vector function. Solenoidal, if our divergence, which is equal to 0, solenoidal. If our curl, the cross product, which is equal to 0, irrotational. Now, f is a function and pi is also, there exists one scalar. The connectivity of this vector function and scalar, it's nothing but f equal to gradient pi, a scalar potential function. Line integral. So we are going to integrate the particular way along the line for the closed curves. It's very important. The closed curve, the meaning of the closed curve, the faculty is expecting that the student should possess the knowledge of the closed, that is starting point and the terminating point should coincide. Next, surface integral. The integration which is used to calculate the area of the surface, it's nothing but surface integral. For this, the integration, the basic formula to be recalled. And we have to understand surface. What is the geometrical shape which is given to evaluate the surface? So Bloom's second level. So these two levels correctly we have to apply to find the solution. Volume integral. What is the difference between surface and volume? Surface in 2-dimensional, volume which is in 3-dimensional. The surface integral, volume integral, line integrals, the three integrals, the relationship between the transformation from line integral to surface integral, line integral to double integral. Now we can see the Green's theorem, Stokes' theorem, and Gauss divergence theorem. All these theorems, transformations between line integral and double integral, line integral and surface integral and integral over volume integral. The relationship among these integrals, these theorems are, the student should possess this knowledge. So now we will move to Module 5. The Module 5, the syllabus is partial differential equations. The partial differential equations, which is framed by eliminating arbitrary constants and arbitrary functions. Solutions of first order linear equation. So the linear and the first order, the faculty is expecting that students should recall what is first order from so far what the students studied. Linear, yes, if the degree of the particular highest derivative should be 1, then it is a linear equation. So the complete study of linear equation regarding Lagrange's linear equation in this particular, the Module 5 syllabus, partial differential equation, which is focused. Non-linear, specific method, Charpit. If Charpit method it is there, the syllabus which is not mentioned, the standard forms, it is understood that standard forms. 6 standard forms at Chartpit to solve the non-linear partial differential equations. So it's a beautifully very strong concept oriented the course which is framed for mathematical transform techniques by the Department of Mathematics, Institute of Aeronautical Engineering. Myself, Dr. Jagadha, Associate Professor for this course coordinator. Now, the faculty is expecting that from this mathematical transform techniques course, what the student should gain the knowledge. That is, the students will try to learn. The first module is our Laplace Transform. So, the transformation of ordinary differential equations in the Laplace field and its applications. Already, to solve the ordinary differential equations, the general solution is complementary function plus particular integral, which already exists. Then why we have to study about Laplace? While using the Laplace transform, the time consuming, if the integration is very complicated, and moreover, thus the ordinary differential equations from calculus to algebra we are converting by the Laplace suitable correct formulas applying. The second one, the faculty is expecting from the second module, from the Fourier Transform, the operation of non-periodic function. The word non-periodic. Then what is periodic? The student should try to learn. If it is periodic, there is a different curriculum. Fourier series is there. Our curriculum is non-periodic. So this is the basic knowledge the faculty is expecting from the student should possess. And the third one, the concept of multiple integrals for finding areas and volumes of physical quantities. Multiple integration. So the faculty is expecting that from the definite integral is the origin for this multiple integrals. The definite integral over a to b f of x dx, which is connected to one variable. If it is connected to 2, double integration. If it is connected to 3, triple integration. Whether it is double or triple, in common, multiple integrals. So the double integral, which is used for areas, triple integral, which is used for volumes. This is the way the faculty is expecting that the student should learn from this course mathematical transform techniques. The fourth one is the integration of several functions by transforming the coordinate system in scalar and vector fields. What is scalar? What is vector? The difference between scalar and vector. What is coordinate system? Whether it is in Cartesian or it is in polar, everything the student should possess. He will be trying to learn. And the fifth one is formation of partial differential equations. So, our complete the 5 modules: Laplace transform, Fourier transform, multiple integrals, vector differential calculus, partial differential equations. From that, these are the course 5 objectives. The faculty is expecting that the students will try to learn these mentioned ones. Now, course outcomes. The course outcomes, that is, it's nothing but which is measurable, which is capable of being assessed. The course outcome is nothing but the student should have the knowledge about the course when at the time of completion of the semester for that particular course. Now, this mathematical transform techniques, the first year BTech second semester. So at the end of the semester, the faculty is expecting the student should be evaluated. What is the knowledge he gained upon the completion of this course? So for that, the course outcomes, the course parameters are designed. The first, our module is Laplace Transform, for which this is course outcome 1. This course outcome, that is which is framed according to the formula, that is the student should be able to do plus behavior plus resultant evidence. This is the formula for, that is a relationship between course outcomes and program outcomes. Now, this is the first one, course CO1. Understand, that is the Bloom's 2 levels, this course outcome which satisfies. Describe the Laplace and inverse transform to various functions, that is continuous, piecewise continuous, and step and impulsive functions. The second one is CO2. Interpret. So we can see the first one, describe, that is the action verb which is used. That is Bloom's second level action verbs. Interpret the properties of Laplace and inverse Laplace for a function of a real time to a function of complex variables. Here, the apply, that is a Bloom's third level which is used here. Next is CO3, that is make use of the integral transforms which converts operations of calculus to algebra in solving linear differential equations. So now our module 1, Laplace Transform, here 3 outcomes, CO1, CO2 and CO3. So 3 outcomes are written for this module 1. Now, we can see the syllabus of the Laplace Transform. We can see it here. How this syllabus, which is connected, based, our aim is the student should possess the knowledge of complete the syllabus, the knowledge, the skill of this Laplace Transform upon the completion of the course, for which the course parameters are designed. The course parameters are, these are the parameters are designed for our module 1, 3 parameters. The first one, we can see it here, piecewise and Laplace linearity. This everything we covered, the course outcome 1. Put together Laplace and inverse Laplace. The second, we will have a look over here. The second one, the properties of Laplace, put put together, we given a course outcome 2, that is apply 3 levels which satisfies according to Bloom's. The next one is applications to ordinary differential equations. If the differential equation is given using Laplace and inverse Laplace, and particularly here we can see the third outcome here, that is make use of, that is Bloom's third level action verb of the integral transform, especially that is calculus to algebra. This is the transformation which is taking place in the solution of, to find the solution of linear differential equations. Because the steps which we are following here, we can see it here, the syllabus, convolution theorem, and applications to ordinary differential equations. For this especially, the differential equation, what is given? We are starting with, we are applying Laplace transform. And what is the conditions which are given, which are substituted there? And Laplace of derivatives formula we are recalling and grouping. And finally, we are finding inverse Laplace transform. So when we are starting, we are applying the Laplace, which is converted into calculus to algebra. So for which a separate course outcome, which is designed here, make use of the integral transforms, which converts operations of calculus to algebra in solving linear differential equations. So 3 course outcomes, the course parameters, which is designed for our module 1, Laplace transform, for the course, the subject, mathematical transform techniques. So this compulsory, the complete the syllabus knowledge to get the course outcome. This, based on this, the questions will be prepared. Next, we will move to the course outcomes for our second module. So the second module is our Fourier Transform. Here we can say it, course outcome 4. So the first one is describe the Fourier transform as a mathematical function which transforms a signal from the time domain to the frequency domain. Understand the Bloom's second level. And CO5, it's nothing but interpret the non-periodic functions. To gain how we are going to assess by Fourier integral and Fourier transform. Here apply. Here CO6, course outcome 6, identify the properties. So many properties are there related to Fourier transform. So this particular problem, which property is suitable? So we have to identify. Now describe, that is Bloom's second action level. Interpret and identify, that is Bloom's third level, the action verbs which are used it. So we can see the syllabus here. The syllabus, if you're noticing, the syllabus here, Fourier integral theorem, Fourier sine and cosine integral is there. And from which the Fourier integrals, Fourier transform, Fourier sine and cosine, this all put together infinite, and property finite. This is our syllabus curriculum. So the student should possess this complete curriculum knowledge. So for which these are the course outcomes. So first one, the transformation, simple problems, that is, which transforms signal to from time domain to frequency domain. Understanding level questions will be dominating in CO4, and Fourier integrals and transformations, the non-periodic functions, will be dominating in course outcome 5. Properties oriented, that will be dominating in our course outcome 6. We can see the syllabus once again. So here full completely the simple one, understanding level questions 4, and non-periodic functions 5, properties oriented 6. So Fourier transforms, this is our second module. To complete the syllabus of Fourier transform, the faculty is expecting compulsory, it is must at the end of the course, at the end of the semester, the student should possess the knowledge for which the parameters are required. Those parameters are here in the form of CO4, CO5, and CO6. So based on this, we have a system in our college, Institute of Aeronautical Engineering, the question bank. The questions which are prepared satisfying Bloom's these levels, and according to the course outcomes, the questions which are prepared. The next we will move to our third module. Our third module is course outcomes, that is multiple integrals. For the multiple integrals, we have given the course outcome which is CO7, that is definite integral, which is the origin for our multiple integrals. So the calculus to a function of two or more variables, that is from definite integral to multiple integrals. 2 means double, if it is more, multiple, that is triple integral. In calculating the area of solid bounded regions, it is understood that if it is more, triple, that is volume of bounded regions. So now the Bloom's is applied. We can see our syllabus. So this is our syllabus for our multiple integrals. That is the double integral, evaluation of double integrals in Cartesian form, polar form, change of order of integration. That is, if the integration is very complicated one, this will help. Change of order of integration. If it is surface, the particularly surface area, double is used. The volume of your region, triple is used. Whether it is double or triple in both Cartesian as well as polar. Suppose Cartesian is given, we want to convert it into polar. So the transformation of coordinate system. So the complete this syllabus curriculum, this multiple integrals, the module 3, the faculty is expecting that it is must to the students should have the knowledge upon completion of the course. That is, once the semester of this particular subject for this particular course is over, the student, the teacher, the faculty who is expecting that he should possess this, upon the completion of the course, he should possess this knowledge. So this is the connectivity which is given our course outcomes. Next, we will move to the course outcomes. we can say that our fourth module is vector differential calculus. The vector differential calculus develop the differential calculus which transforms vector functions, gradient, divergence, and curl to the real-world engineering problems. That is, we named it as course outcome number 8. Apply level, the questions will be framed. All this framing the questions under tutorial question bank, the system which is available in our college website. And regarding question bank also, which is already separate videos are done, which is released in YouTube channel. Now, the next one is apply the integral transformations to surface and volume, line and surface of different geometrical models in the domain of engineering. There is a geometrical model. Suppose it is a tetrahedron, cube, cuboid, in triangles, whatever the geometrical shape, how to find surface, how to find volume. To find that, how the line integral, which is going to help us, how the surface integral, everything CO9, which is framed. So up to 3 levels Bloom satisfying the questions which are framed. The last one is CO9, for which integral theorems, Stokes, Green, Gauss divergence theorems, these theorems which are used to calculate the areas as well as volumes. If it is triple integral, if it is not mentioned here also, that is a Bloom's taxonomy, the second level. If volume it is there, it is understanding level, it is 3 dimension. If double integration is there, the understanding level, it is 2 dimension. So the 2 dimension which is used to calculate surface, 3 dimension which is used volume. So apply. So completely the fourth module, vector differential calculus, 3 course outcomes, 8, 9, 10, which are framed. Now we will do how it satisfies our syllabus. So now this is our scalar and vector point functions. This is our fourth module, vector differential calculus, the syllabus the teacher, the faculty who is expecting the student should possess. That's what the course objectives, which is framed it. Now, this is course outcome, compulsory. It is must that the student should possess upon the completion of the courses, for which the faculty should select the correct course parameters. Those parameters are here. That is CO8, CO9 and CO10. These 3 course outcomes which will make the students to gain the complete the knowledge of module 4, that is vector differential calculus. He will be gaining, and based on that the questions will be prepared. Next we will be moving here. Before that, we can see it, a gradient, divergence, curve. You can see the syllabus. So the completely gradient, divergence, curl, everything we kept it CO8, line and surface integrals. These all we kept it under, that is CO9, and the integral theorems, Green, Stokes and Gauss divergence. These theorems are CO10. That's what our syllabus curriculum, which is to gain this knowledge, that is the faculty is expecting that the student should possess this course. In the course, Module 4, Vector Differential Calculus knowledge, complete knowledge to evaluate whether he gained or not, to evaluate the course parameters are designed in such a way. The next we will move to our module 5. This is the last module of this course, Mathematical Transform Techniques. Here we can see it here. That is the course outcome, Bloom's. Here are two course outcomes which are kept. That is, explain Lagrange's linear equation related to dependent and independent variables. First, the partial differential equations, when you are touching, the student should recall what is dependent, what is independent variables, as the variables are playing, and what is the differentiation and what is partial differentiation. The difference also the student should possess, and he should, what he studied in the earlier classes, he should recollect. After recollecting, he has to do the comparison, the linear equation, but in our curriculum, specifically Lagrange's linear equation. So what is Lagrange's linear equation? And ordinary linear equation understanding level 2, satisfying that which is framed under CO 11. Next, the course outcome 12, that is, solve the non-linear partial differential equations. Specifically, Char-Pit method. If Char-Pit method it is there, it is understood all the 6 standard forms also existing. So all this apply. Now we will comparison. We will move it whether the course parameters what we selected complete, whether the students will possess the knowledge upon completion of the course or not. We will check it. So this is the syllabus for our partial differential equations. So now here how to frame the partial differential equation, that is eliminating arbitrary constant and function. Here the syllabus which is given, first order linear equation. So here linear equation, Lagrange's linear equation, that we can see it here. So the linear oriented we kept your course outcome 11, non-linear, which is under separate course outcome 12. So totally for the Laplace transform 3 course outcomes, for Fourier transform 3 outcomes, multiple integrals 1 course outcome. The fourth module, vector differential calculus 3 outcomes, the last one, partial differential equations 2 outcomes. Put together 12 course parameters are going to help to gain the complete syllabus knowledge of this particular mathematical transform techniques. Once the course is over, the semester is over, the course is over, the student will be, it is must, the faculty should make the student to possess the knowledge for which these are the parameters are helping. So in such a way, the 12 course outcomes which are framed. Now, the knowledge level of this. Now, the 12 course outcomes, we have seen it. That is, the Bloom's 3 course outcomes, the understanding level, the questions will be prepared. The other, the 9, it is apply. That's what here we can see the bar diagram, which shows that understanding 3. If understanding is there, then compulsory remember plus understand. If apply, remember plus understand, then apply. As it is specifically, it is the BTech first year, the analyze and evaluate and create questions are not concentrated. So analyze, suppose the question, one geometrical figure if it is given, then the student should have what are the different analyzing he has to, comparison study he has to do it, and for that basis calculation, and the last one assembling of everything, the new one to be created. So in this particular curriculum, these levels we didn't concentrate, only these 3 levels concentration questions which are prepared. So totally we can see it out of 12, the 9 course outcomes which are prepared up to 3 levels. Now, program outcomes. These are program outcomes which is at the end of the, because outcome based education, it's a thing. It is focused on measuring the student's performance through the course outcomes. These outcomes are evaluated by stating the knowledge, skill, and behavior the graduate of your program and after 4 to 5 years. But the program outcome, which is the student should satisfy the requirements of the program, engineering program, at the end of the engineering program, it should be done. Now the program outcomes, how they are assessed. Now we can see it. Totally 12 program outcomes are there. These programs outcomes which are described by NBA, National Board of Accreditation, and they should reflect, that is the 12 that program attributes by MBA. Such a way, ours, among the 12 program outcomes, our syllabus, mathematical transform techniques, which is connected to how many program outcomes. The total program outcomes 12 are there. The first one is engineering knowledge. The second one is problem analysis. Third one is design and development of solution. Fourth one is conduct investigation of complex problems. Fifth one is engineering and society. And the next one is environment and sustainability. The next, ethics. The next, individual and teamwork and communication, management and finance, lifelong learning. Like that, 12 program outcomes are there. In the 12 program outcomes, the mathematical transform techniques, the course, how many program outcomes it satisfies. It satisfies among the 12, first one and second, the 2 program outcomes it satisfies. For the strength, the first one which is satisfied more, 3, the strength is 3, and second one 2, and the fourth one is the strength is 1. How to assess this program outcomes, the success? That is, it is assessed by, because assessment, we have seen it starting of course objective. The course objective is what is the students expected to know, whereas assessment, that is a tool to prove what is the student should have about the course information, for which CIE, continuous internal, that is the mark divisions, the 100%, 30%, that is our internal mark division, for which 20% is CIE, the continuous internal assessment, and the next in the form of AAT, that is concept video or tech talk, 10% which is given. So now we can say it, these 3 program outcomes are connected to our course, mathematical transform techniques. Here we can see it, the 3 which represents high level, 2 represents medium, and 1 represents low. So here the last one, which is assessed by conducting seminars, conference, and research papers. So we can see it now here. program specific outcomes. Here we can see it, PSO1, 3 are there. This is, here we have taken this program specific outcome for the particular branch, aeronautical branch. Here in our college, the mathematical transform techniques, which is being taught to aeronautical engineering, EEE, and electronics and communication, civil and mechanical engineering. Here, this program specific outcomes, especially for aeronautical engineering, that is a specific engineering course. Now, our subject course, which is connected to PSO1, the strength is 2. How is it assessed by seminars, conference, and research papers? So now here we can see it, just now we have seen our course which is connected to PO1, PO2 and PO3. That is, among the 12 program outcomes, 3 are connected. So we can see it, and a program specific outcome 1 is connected. The course outcome, that is PO1, it satisfies, and that we can see it here. This is our PO1, that which is satisfies. And CO2, that satisfies 1 and 2 and 1, and CO3 which satisfies 2 and 4. That is, we can see it here, 2 and 4. And the next one is, so CO3, which satisfies even a program specific outcome, the first one. How they are connected? Here we can see it, the PO1, describe the Laplace inverse transformation. This program outcome 1, it has 3 elements it has, whereas 2, it has 10 elements, 4, it has 11 elements. Now, our course outcome, among the PO1 3 elements, how many elements it satisfies? It satisfies 2 elements. So what is the program outcome 1? Here we can see it. The program outcome 1 is, that is, apply the knowledge of mathematics 1 element, science 1 element, engineering fundamentals 1 element. Like the 3 elements are there. These 3 elements, our course outcome 1 satisfy how many elements? For that, like this connectivity giving, it satisfies 2 elements. Such a way, CO2, that course outcome, among the PO1 3 elements, how many it satisfies? It satisfies 2. The next one is here, CO3, the PO2 is there, that it satisfies PO2. Totally 10 elements are there, that we can see it here. That is, identify, formulate, review research literature, and analyze complex engineering, then conclusions, principle of mathematics, like that. 10 elements are there. In the 10 elements, our course outcome 3 satisfies 4. For that, here the connectivity, course outcome, how which is connected to program outcome, such a way which is written here. That is, describe the formulation of integral transforms which converts complex engineering problems using apply operations of calculus to algebra along with principle. These all, the bold one, the elements to reaching substantiated conclusion by the interpretation of results in solving linear differential equations. So the totally our PO2 here, the PO2 here, total 10 elements, our CO3 which satisfy 4. In a similar manner, our 12 course outcomes we have to check. Now, In this specifically, you are CO3, which is satisfies two program outcomes. That is not only two, even four, which is also connected. That is a four, which has nearly 10 elements. One is satisfied, and specific. That is the specific here. This is the curriculum related to how it is connected to the branch for the explanation purpose, which has taken aeronautical engineering. So specifically it is connected to one, that we can see it. So that which is connected here, that is it. Totally the particular branch, they have this many specific outcomes. For ours, that is the course outcome tree, which is connected to it. That's what here you can see it. So which is connected. The similar way we have to do even other outcomes also, the connectivity. This is the CO and PO mapping, which is very, very useful for the institution, that whether the students, how far their performance in each course, for which the weightage of even CO and PO mapping should be specified. Even the weightage should be given in the 3-point scale, that we can see it now. The other course outcomes, we can see it. So we can see it here. The CO4 is there, which is connected to our PO1. That is the total elements is 2. That is out of 3, 2 is connected. CO5, PO2, that is total actually nearly 10 are there, 4 are connected. And here CO6, that is also out of 10, 4 is connected. Here we can see it. CO5, which satisfies, not CO6, which satisfies our program specific outcome. We can see it. This which is satisfies. So this is the way the connectivity, total how many elements are there in the program outcomes. Our course outcome, when we are mapping, how many elements are satisfied, for that the number of key competences, separate column which is filled. So the next one is, we can see it, our, that is CO7, that is our multiple integrals, how which is connected. It satisfies our program outcome 2. That is 4 elements are satisfied. That is apply the formation. The totally, we can see it here. Here totally identify, formulate, review, research, literature, analyze. Like the nearly 10 elements are there. In the 10 elements, ours is here 4 which is satisfied, and in such a way the C1 P1 mapping which is given, apply the formulation of definite integral calculus to a function of complex engineering problems of 2 or more variables using principle of measurements in calculating the area of solid bounded regions by the interpretation of results. So now we can see the 8, 9, 10, that is the vector differential calculus, the parameters that the student should possess the knowledge upon completion of the course, for which the course outcomes 8, 9, 10, which are mapped to the program outcomes 2 and 2 completely, the vector differential calculus which is mapped to program outcomes 2. It satisfies among the elements, 4 elements are satisfied. Here we can see it. The 4 elements, that is formulation, complex engineering, and we are using principle of mathematics, interpreting the results. There are 4 elements which are satisfied. So here which is written 4, 4, 4. So the last one is actually the partial differential equation. CO11, which is connected to our program 1 and 2, and here CO12, which is connected to PO1. Here we can see it. that is 11, which is connected to 1. Here we can, this is our 1. It has 3 elements. So out of 3, the 2 elements, that is complex engineering and principle of mathematics, 2 elements which are satisfied, whereas course outcome 11, which are mapped to program outcome 2, satisfy 4 elements are required, are satisfying this course 11 to P2. So such a way the connectivity, that is the program outcomes, that is at the end of the program, the student should have, uh, should satisfy, should fulfill the requirements of the degree engineering program. That is this, because the 12 program outcomes which are described by NBA. Now, they are reflect of MBA requirements of the particular degree program engineering. Now, the connectivity, that is CO11 and CO12, in such a way, the particular program outcome, how many elements it has, our course outcome, how many elements it satisfies. According to that, the number of key competencies are written. So the next one, we can see it here. So here we can see it easily. Our course outcome 1 is there. Here this is program outcoming. So totally it has 3 elements. Our CO1 satisfies 2. CO2 satisfies 2. CO4 satisfies 2. And the last C11 satisfies 2. The next one is program 2. It has 10 elements. Our CO3 satisfies 4 elements, and here we can see it here. CO5, 6, 7, completely up to 11, all it satisfies 4 elements. 3 not there, it is not at all connected. And PO4, it has 11 elements, and here CO3, it satisfies only 1 element. Coming to here, program specific outcome. That is, here we have taken specific outcome, that is regarding the specific engineering program. Here we have taken aeronautical engineering related that particular branch, for which the program specific outcomes 222. Ours with 2 elements. Our CO, here we can see it here. CO3, which satisfies 1 element. This is the way the table, which is how many elements our course outcome satisfies, how many elements among them, which is written to this table, which is filled on that basis. Now we will do the percentage. It's a very easy way the percentage to be calculated. That is, here the 2, which is replaced by the percentage calculation. That's 2 divided by 3 into 100, the percentage. Here also 2 divided by 3. Whereas here 4 divided by 10, the percentage we have to calculate. We can see it in the next slide. So we can see it here. The connected one, 66.7, that is 2 divided by 3 into 100. Whereas here 4 divided by 10 into 100. Here 1 divided by 11 into 100. Here 1 divided by 2 into 100. So this is the way the percentage calculation which is done. Because why we are doing this percentage calculation? Because CO, PO, the mapping, that each course outcome, how which is connected to our program outcome, it should be specified. The weightage, that scaling to be done in 3-point scale, that scaling is here. So we can see it, that's the relationship, the scale of 3. So if you are getting the scaling 0, there is no correlation. If it is 1, low, 2, medium, and 3. The percentage also for the 1, so we can see it, the percentage what we have calculated now, we have seen it, the before slide. We can see it here, 66% is there. Here 40% is there. Whereas here we can see it, this 9% and here 50%. So for the percentage, if it lies between 0 to 5, no correlation. It's a poor performance. If it's 40 to 60, moderate, and we can see it. Up to 40, it is low, and up to 60, it is moderate. If it's 60 to 100, it is high. For that, the strength which is given 0, 1, 2, 3. So we can see it according to the percentage wise, because in the particular place we have noticed it 66%. Here we can notice that it is a 40%. That's what it is. 2, which is the strength, which is the point scale. Here, which is we noticed it 9%. Now we can see it here 66. So that's what 3 here 2. So according to the strength, they are marked it. So this is the articulation matrix, that is CO and even PSO also we can see it here. It's a 2 because of 50% we obtained here in this particular place. So now this course, our mathematical transform techniques, the faculty, so 45 the classes, each module, it's allocated 9 sessions, 9 classes to be taken, for which the preparation to be done, satisfying our course parameter, course outcome for the Laplace transform. If you are taking 3 course outcomes, 3 course parameters are designed or framed, that compulsory the student should possess the knowledge of complete the syllabus of Laplace transform upon completion of the course. That is the end of the semester. So for which the 9 classes satisfying the course parameters, that is the course outcomes. So the questions which are prepared. So this is the first one weekend, the first class, define Laplace transform and its properties. The second class, third, like that, all the 5 modules. This is a sample which is given for the first module. So 45 the theory classes and 15 practical classes will be taken. So now, what is the modifications, the gap in the syllabus we can do it. So now the complete syllabus, if you are taking the mathematical transform techniques, Laplace transform, Fourier transform, multiple integrals, vector differential calculus and partial differentiation. And if the numerical methods, it is missing there, so better we can include the Newton-Raphson, Lagrange's interpolation, and method of least square, that is if the points are scattered to fit in the curve, and Ranguta method. This filling also, if it is included, for that seminars we can contact our MTL courses, that which will satisfy our program outcome too. Next, even the Fourier integral transforms, and for which also seminars, if we contact, it satisfies program outcome 1, and more encouraging the students to solve the real-time applications and prepare towards competitive exams, that a program specific outcome of 1. So now this, if it is there, more which will strengthen the mathematical transform techniques course to enrich the students' knowledge about the course. So we will come to a conclusion of this topic, mathematical transform techniques. First, the course descriptor that we discussed about it, for which we have taken the Bloom's taxonomy, the 6 levels. Remember, understand, apply, analyze, evaluate, and create, and course outcomes, 12 course outcomes, and program outcomes. Because the course outcomes and program outcomes, the relationship between, that is it should be the mapping. Once the mapping is over, then we can evaluate the program outcomes, for which we adopted the 3-point scale, the strength and also which is showed, and the course outcomes, how they are connected to the course outcomes, how many elements which are satisfying the specific the program outcomes elements, even the percentage also calculated. Everything in detail, we discussed it. Now, this mathematical transform technique, this subject, even the videos specifically which is done, the complete the syllabus, theory oriented, nearly 40 videos are done, and problem solving, nearly 15 videos, definitions, terminology, 5 videos, question bank, 5 videos. This put together nearly more than 50 hours. The videos are done. So the students can utilize these opportunities very well. All these videos preparations are done by Dr. Jagadha Saravanan, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Now, these videos to prepare the reference of the books which are taken, that is S. Chand publication, Professor Iyengar's book, and B.V. Ramana, that is Professor those books, and Professor Gairwell, The Higher Education of Engineering. These are the books which are referred for the problems selecting. And more we can see it here. We in detail we discussed outcome-based education. That is, it is completely outcome-based education to satisfy. That is a fundamental. It is a student-centric learning. That is teaching and learning processing. Completely these videos, which is based on teaching and learning processing, the videos are prepared. And we discussed about course outcome, program outcome, and mapping and strength. Here, totally the assessment tool we are using, our internal, that is continuous internal assessment, 20%, and 10%, that is concept video and tech talk. The remaining 70% were SE exam, that is the end semester exam. These are the assessment tools to analyze, helping how the course, upon the completion of the course, how much knowledge the student possessed. These assessment tools are helping. So completely the outcome, the global, the language of education, that it's not only adopting, we have to maintain the outcome-based education. So which will help the faculty to make their innovative teaching, and even the students the employment opportunities in global way they will be acquiring. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.